To find the domain of a combined function, there's a couple ways you could do it. You could examine the domain of them separately and then take the intersection of those sets, or you could just look at the join function and use some common sense. It would be basically the same thing. But let's take the more normal approach, which is examining the domain of each f and g and then applying the intersection of those two, as I've stated up here. And I'll review what intersection and set, basic set logic as we go too, if those are terms you don't remember from algebra. But if we're looking at function f, and this is returning back to what we talked about in our function video, well, to find what the domain is, we want to look for where it is defined and where is it not defined, right? Because a mathematical function, we generally assume it's all real numbers except for where it doesn't work. So with division, recall that you're not allowed to divide by 0. So the only location, the domain of f would not be allowed when the denominator is equal to 0. So in this case, we could say, well, the denominator is x plus 1, set it equal to 0, and that would be what is not allowed. And if we were to subtract 1 from both sides, we'd have that x is not allowed to be -1, which quite obviously would make 0. And again, you can't have 1 divided by 0 in math. That is just not a defined operation. And I don't think I reviewed this earlier, but this might be a good time to talk about why can't you divide by 0? Because this is something that I remember, my teachers saying a lot, but I didn't necessarily understand, well, why is that? And I think it's easier to remember if you know why. So I'll just explain it in a way that I'm used to, just using an example. Let's say that you have 6 friends and you have $0. You want to let's just think about what happens when you divide by 0. Let's start by thinking about what is 0 divided by 6 using these quantities. So if I have no dollars, but I have 6 friends, I could think about, well, how do I divide $0 between my 6 friends? Technically, taking 0 and dividing that up is fine. You could say I could share my vast wealth with all of you. You all get $0. Cool. I can share $0. It just amounts to nothing. All of those people each get $0. And it does make sense. But if I think about flipping the idea, let's say that I have $6 and no friends. And I wanted to take my $6 and share it among no friends. Well, how do I take 6 of something and spread it to nothing? If I think about the sharing idea of division, it's impossible to share something with nothing because there's nothing to share with. And you might think, well, isn't it just $6? Wouldn't that make sense? But no, that would be if you have $6 and you're splitting it to one person. There is no way to divide to 0 things. It's just mathematically, it's a problem area. There's other ways to think about this, but I think it's kind of, I like this example. It's also conclusive proof that having friends is better than having money, and that friendship is more valuable than money. But that's just a silly example that I like to say. And if you ask Siri, she'll say something kind of similar. If you ask her, why can't you divide by 0? Or at least she used to. Anyways, I'm getting off topic. Back to the example f of x. Basically, we were not allowed to divide by 0. Now, we know why. You might already kind of understood that, but that's one way of explaining it. But basically, remember, the domain is where it is allowed. So since it's not allowed to be -1 in this case, the domain is all other real numbers. So it's all numbers from -infinity to -1 and from -1 to infinity, but it does not include -1. And that's how we just write all real numbers except for -1 in the case of the domain. Or, we could graph it out and we would have an open circle on -1 and everything else would be part of our set. Now, we also want to look at the domain of g, so we could call this df the domain of function f right there on that number line, and looking at g. And since g is a radical function, we did one of these as well in an earlier video. Remember, with radicals, there's a problem when the inside of a radical is negative. So we want the inside of the radical to be strictly positive or 0. And so I could solve the domain of g by solving, rather than a negated equation, like I did over here, using a inequality. I could set the entire inside. I don't need the square root, because only the inside needs to be positive, not the whole thing. The inside x minus 1 needs to be positive or equal to 0. And then if I add 1 to both sides, I will get x must be greater than 1. And so I would get this set of numbers from 1 to infinity as my domain for g of x. So I'll just write that as d sub g, which just stands for the domain of g in this case. And the notation doesn't really matter what I'm writing. I'm just trying to differentiate them. And you know what I explained up here is that the intersection of the two domains would be the domain of the joined function. So actually, and that's the case for all three of the sum, difference, and product functions. If I just take the intersection, an intersection is the set symbol where if I were to take this larger set and take the intersection of that with this new set here, this would be the set symbol which would join them together. But not worrying too much about set operations and set logic, because for the most part, that's not that important to our class. But what is important is kind of understanding, well, what does that mean? Basically, in order for this to make sense, and I think it's a lot easier if we just examine this function, well, neither one of those things is going to be allowed, right? X can't be -1 because that would cause a problem here, and it can't be negative because it would cause a problem here. So that's just a way of saying, well, it has to be allowed in both of these sets. The intersection is the overlap. Basically, any number which is in both D's domain, F's domain, and G's domain would be in the domain of these joint functions. So basically, my point is the domain of F plus G, and the same would go for F minus G and F times G, would be the overlap of these two sets. And so basically, it would be numbers that they have in common. And if you take them and draw them on top of each other, I don't know if there's a way that I can copy paste stuff. Oh yeah, I can. So I'm just going to do this so that I don't have to redraw them all again. Because usually this would be how I would teach how to do. Whoops, I didn't want to do that. Maybe I can't do what I'm trying to do. Anyways, I'll just redraw it. Sorry for wasting time. I generally plan out what I'm doing pretty well in videos, but sometimes just let it fly. Okay, but basically if I'm looking at them on top of each other, any numbers which are in both sets at the same time would be in the intersection. So if I'm trying to figure out what is the intersection of this set with this set, it's going to be the overlap. And if I put them side by side, I can tell because it's going to be where they're both shaded. So basically, from 1 to infinity is in both sets. That's going to be the intersection. And that would be my hybrid domain of the sum function. And it's going to be the same for difference and product function. The one that is a little different is the quotient function actually has one more curveball to it. And that's, it's stated above here, but it says the domain of the quotient of two functions, should be an S there, is the intersection of each domain excluding the values of x for which g of x is equal to 0. So when I'm thinking about f divided by g of x, the one thing that's different is it's actually involving division. And as I said before, right, division can cause problems. But if I think about each individually, well, this function had some problems, this function had some problems. So all their problems come together to form a more restrictive set based on the intersection. But we're also making another problem because we're introducing another division. So it's like there's a new thing you got to worry about. And if I'm looking at it, well, first of all, this can't be negative, this can't be 0, but we introduce another quantity which can't be 0, which is g of x. So that's kind of what it says above, is also g of x cannot be 0, meaning the whole g function isn't allowed to be 0. In this case, it's going to be that one specific boundary point, which again I could solve that. Sorry, my dog is flipping out behind me for some reason. Which would just be setting the denominator equal to 0. But basically, it's always going to, with a square root function, it's always going to be on that boundary point at 1. And basically, 1 is going to be the answer to this, And really, this is no longer allowed to be 0 in this case because we're dividing by it, because it's also on the bottom after dividing. And basically, x is not allowed to be 1 because I could square both sides and add 1 to both sides to find that out. And so on top of the already restricted domain, I also need to impose that condition, but that would simply leave us with the domain of f quotient g to be from 1 to infinity, no longer including 1, because that's the new 0 that's being introduced, and we can't divide by that. So summary here, the way you could find domain and range of these joint functions is find the domain of each of them separately, apply both restrictions at once, and if you were dividing them, apply another restriction, which is when the g function would be equal to 0. That's way too much about this. To be honest, it's not really super critical skill, but I believe you have at least one in your homework, and I figured I would go in detail with helping you at finding that. Anyways, that's it for this one.